All right. This is joint work with Patrick, who's sitting up front, and a whole bunch of other people. You can read their names here. For some time now, we've had security concerns about BGP, that updates are not authenticated, so all sorts of bad things can happen, usually do happen. And there have been papers and talks on the subject. And also, of course, that the path attributes with each update are not authenticated either, and this is a source of different updates. And I probably don't need to go into any more detail than this, not in this audience. Another issue with BGP is that it hides information. And frequently we need a way of checking whether people are abiding by policies that they should be abiding by when we get their BGP announcements. And also, when something's going wrong, all we have to go by is the BGP data we are seeing at our own routers. We don't know what others have seen and what the source of the problem could have been. And so there is some thought that maybe we need a richer channel to convey some of the information that BGP is hiding along the way, but only get it when it is needed, not continually flood it. Otherwise, of course, we lose all the scaling benefits. Also, when things go wrong, we need sort of a way of figuring out what was the root cause of something going wrong, because sometimes the effects, secondary effects can mask what the real cause could be. All right, skipping really ahead, we are proposing something we call the internet routing validation or verification. The meaning of V varies by time of day or whatever. And this is an effort to build this richer channel for ISPs to use to verify BGP data. And the idea is that each autonomous system maintains a routing verification server. That could be a replicated server, it could be a distributed server. It can even be replicated to across different ASs, subject, of course, to agreements. We don't know exactly how this is going to happen. And it's really a repository for all of the ISPs, actually the AS's current policy, active policy, all its routing state, that is all the routes received and the routes it's sending, and maybe some historical data, and hopefully some of its configuration. And the idea is that whenever a network monitoring element or something, not necessarily a router, actually hopefully not a router, in some AS, here AS3, wants to figure out if AS1 sent something or what the policy of AS1 is, maybe because it wants to verify something else, it will go and query the IRV of AS1 and get some results. We're trying to do two main things. We're trying to do origin verification. Note that this does not necessarily have to be cryptographically validated. If it is, more power to us, but at least we can have some corroborative evidence that an AS is really intends to advertise a particular prefix. This will not help in the case of or may not help in the case of a really malicious AS or AS has been taken over, but it could help in the case of an accidental misconfiguration where somebody typed the wrong iOS command. And at the very least, an ISP can make sure that its own announcements are reaching other parts of the net, so that when a customer complains that they cannot go somewhere or whatever, somebody at the NOC can go in and check something. The queries are asynchronous, so when you're getting several 100,000 routes after a reset, you don't have to validate all these routes at the same time. You can validate them at your leisure, and you could have kept cached copies of some prior validations that may or may not have some expiration time, so you can check them locally and you don't have to go across the network to verify 500,000 updates. You can also verify the path, and how do you do that? You receive an update. You may want to go to the IRVs responsible for each AS in the AS path and ask things about that. And the idea here is to make sure that all the ASs in the path are actually abiding by the policy of their neighbors, and in fact have you don't actually seeing falsely injected updates. We know how to do access control in databases, or things, at least we think we know how to do that. We can have data presented with different granularities. Customers or peers may want or may need to view different parts of our data, higher detail, more confidential data. Peering agreements are often private. Competitors who are not peers may want to, but should not really get access to that data. This is data that usually gets omitted from the routing registries for good reason. Here's a way, and then nobody can get them, but here's a way where some authorized people can get them. Some part of this could be a service. Who pays for it? I don't know. I'm in research. I'll let others figure this out. And this could be a public service for some kind of data, or I'll show you mine if you show me yours kind of agreement, or anything between. And there is a paper at last week's NDSS. The URL is down at the bottom. And this is very much ongoing work. We don't have all the answers. In fact, the reason we're here is so that you will shoot this thing full of holes, and then we can go patch the holes with duct tape or something. And the questions we have is, do people think that this is something that could potentially be of any interest to anyone? We don't know how well it will scale. I think we'll scale. This is something that needs to be answered, and this is something that that people would consider ever, or maybe we should go home and go get a real job. We are talking to vendors about this, and at least one vendor is interested, and I'll leave it at that. I hope I'm under 10 minutes. Questions, answers? All right. I'll take that as no interest.